Today we're going to look at quadratic functions by identifying the x-intercepts, the zeros, or the roots using a graph. The x-intercepts, the zeros, and the roots are the same thing. The zeros or the roots of a quadratic function are the x-values of the x-intercepts. So basically the x-intercepts where the graph crosses the x-axis would be known as your x-intercepts or the zeros or the roots. And in this case, there are two roots or two solutions. Here's another graph where the x-intercept is only 1. And then the last one, this time, the graph does not even intersect the x-axis, so therefore there are no real solutions or no real roots. To identify the zeros or the roots or the x-intercepts, look for where the graph crosses the x-axis. So here the graph crosses the x-axis at 3, and here the graph intersects the x-axis at -1. So therefore our zeros would be -1 and +3. Now here we can find the zeros in the equation y equals x squared plus 12x plus 32 using another form, but today we're only looking at the graph. So if you look at this graph right here, the x-intercepts are -8 and -4. We can take those two x-intercepts or the zeros or the roots and we can write them as an ordered pair. So this is just another way you can write the zeros. When there's no real zeros or no real roots, which means the graph does not cross the x-intercept, notice that that red line does not even touch the blue graph. Therefore, there are no real zeros, no real roots. And here we have a frown, which means that the a in front of the x squared term is negative. And here again, that red line goes straight to the x-axis and it does not intersect the black graph, the curve. So there are no real zeros, no real roots, no x-intercepts. Another thing that might happen is you might have two real zeros or roots or x-intercepts. So if you look at this graph right here, there are two points at which the graph hits the x-axis. So in this case, our x-intercept or our zeros would be -1 and the other one would be +2. In this case, you see a soccer ball being kicked up, it reaches its highest point and then it comes back down. So the two places where it ends up would be, or begins, first of all, would be at this point, which is an intercept, x-intercept, and this point, which is an x-intercept. So therefore, the x-intercept in this case would be -1, and over here, the ball is going to end up with the x-intercept being 7. Another thing that might happen is you might have one real zero, one real root or x-intercept. So in other words, the graph is going to intersect the x-axis at exactly 1 point. So we look at this one right here, this graph, we see that the x-intercept is -3. Then down here at this graph that's going down in the negative direction is ending up to be +3. So notice both graphs only have one intercept. And then sometimes the x-intercept or the real zero might just be the origin. So therefore, in this case, my x-intercept is 0. I hope you learned something today, and please make sure you go back and you review the graphs, and when the graph crosses the x-axis twice, once, or not at all, then go back to Teams and complete the problems that are provided for you. Have a good day.